Hey everybody, this is day 17 of the May Leetcode Challenge, daily challenge. Hit the like button, hit the subscribe button, and let's solve today's problem by also hitting the refresh button. Uh, Alright, cool. Find all anagrams in the string. Given a string S and non-empty string P, find all the start indices of P, anagrams in S. String consisting of a lowercase English letters only, and the length of both strings S and P will not be larger than, is it 20, comma 100 or 20,100? Seems like a really odd number, but okay. The order of the output does not matter. Okay. So starting at index 0, we have CBA, which ABC, ABC is fully encompasses of, and then also at 6, which also, oh, wait, 1, 2, 3, 4, 5, 6, BAC, which also is an anagram of ABC. Okay. So the idea behind here is using a sliding window. I think the naive algorithm would be to just check every starting index, right? So first check CBA, and then check BAE, and then check EB, and so forth, and so forth. So what's the complexity here? Well, with the length of the strings of S and P, let's call it N, is 20. Let's say the size of string S is N and the size of string P is M. Then it's going to be just N times M comparisons, because you have N place or N minus M place, but roughly N place, O of N number of places to start your substring. And then for each of them, you compare it M times, so it's O of N times M roughly, right? So that's going to be too slow because 20,000 square is a really big number. It's like, what, 40 or 400 billion or something like that? Or 400 million maybe? I don't know. Either way, it is very slow. So the key thing to try to figure out how to solve this is try to create things in a way that you can reuse partial problems that you've solved before, and also try to find an invariant that you try to hold true as you go through. So the thing here to ask yourself, the thing that I ask myself anyway, is how to figure out whether a character or a string is an anagram rather than a string. Well, there are ways to come up with this, and there are ways to figure it out. If you don't know how to do that, then maybe pause the video to kind of, work that out a little bit first. But if you have solved a couple of problems on Leetcode, it comes up a lot. So this is very canonical. There are a couple of ways. There are a couple of general ways to do it, but you could sort both strings and then compare to them with the equal. In this case, it may be too expensive still. Another way is to just count the number of A's, count the number of B's, count the number of C's, and so forth all the way to Z's, because they're all lowercase English. And then just check that they're equal at every time, right? So based on that, that's pretty much all we need to continue with the sliding windows algorithm, or two fingers algorithm, two pointers algorithm. There are a lot of names of it, but that's how I'm going to proceed. So let's calculate, let's just say, let's have a delta array of 0 times 26, where why 26? Well, A to Z delta array. And you could do this in a number of ways, but I'm going to do it with a delta array, just so that maybe that's actually more confusing. But the reason is that basically then another way to represent it is just, let's say a p count array is equal to this, and then an s count, or like s current count maybe, is equal to also this. And basically my idea of a delta array is just p count minus s current count, or the other way around. It doesn't matter because you're checking for zeros. So that's basically why I have a delta array. And then now, initially, let's populate the delta array with the things that are in P, right? For character in P, well, let's convert this from the character minus the ordinates of the character A, and then from that get the delta plus equals to 1, right? So that allows us to count the number of characters in P. And then now we just have to process the S array, right? So now for C in S, so how do you do this, right? Well, I'm going to write some other things as well. Let's say n is equal to the length of the P, and then let's enumerate S so that we have the index. So let's see, if index is less than n, well, let's say if index is less than n, that means we just focus on adding, but we do that even if it's bigger than n. So let's change that a little bit. So we do the same thing as we had before on delta, but only in this case we subtract. Subtract 1. We remove S sub index, which is C, by the way, from the delta. And then now, if index is greater than or equal to n, and by that it means that, and you can actually check a little bit earlier, really, but it doesn't really matter because if it's less than n, you could prove to yourself that there's no way that this following condition is going to be true, which is that all of delta is equal to 0, right? So now, if index is greater than n, then we can check that delta is all 0, right? So we can actually do n for all x is equal to 0 for x in delta, something like that, right? Then in that case, also we need a result array just to return the results. If that's the case, then we append index because index minus n, because index is the current index and index minus n is the beginning of the string where that begins. We will have to double check a little bit on off by 1 and stuff like this, because I think on the nth character, if index is n, that means we have to remove 1 more. So I think this is actually this, because if index is n minus 1, that means you have push n, there are n characters in the delta, right? And this also maybe I have, let me think. Yeah, minus 1, I think. Well, yeah, sorry. This is just to kind of make sure that's right. I'm just thinking, what I was doing was that I was just thinking through the index of like, well, what happens when index is equal to n? What happens when index is equal to n minus 1? And I was like, oh, now if index is n minus 1, then you want it to start at 0, for example. And so that's what I was just thinking through, because it's inclusive, right? The way that we were doing it. And then now also, if index is greater than or equal to n, now, well, I think we have to actually put it here. Because we have to remove from the set. So now we, okay, let's rewrite this a little bit, this comment. We add s of index to the current window. And because of the negative of how we did the delta, which means we move C is equal to this from the delta, yeah. And now we remove s of index from the current window. I don't know why Windows is on code, I forgot why. Which means we add C equals index. Well, no, that's not true. Hang on. Actually, I watched it a little bit, but what we want to do is actually remove index minus n from the current window, right? So that means if index is n, you want to remove the first element. If index is plus 1, you want to remove the second element and so forth, which means we add back to the delta, right? So then now we do delta of s sub index minus n minus order of a, or the ordinal way, and put it back. And I think that's pretty much it. Let's run some test cases. Yeah, so that looks okay. Let's test more test cases, because why not? Something like that. And let's test some empty strings in it just to see if it works. And I don't even know what the expected answer is for empty strings, so for either of them. So so let's kind of check that out. Cool. Yeah, so that looks pretty okay. I guess empty cases or empty strings are not in the reference solutions or the test cases, or otherwise, that would air it out. But yeah, cool. Let's submit this and let's see. Cool. Yeah. So what's the complexity? So we used technically a constant amount of extra space by keeping track of delta, but more technically speaking, this is O of alpha, where alpha is the size of the alpha bit that we take advantage of, which is not technically explicitly in the problem, but it is still part of how you would do the analysis. So given that we have O of alpha extra space for each character, we just do O of 1 adding and subtracting, and then we do this thing, which costs O of alpha again. So the n time running algorithm of this problem is O of alpha times n, where n is the size of S, and with O of alpha space. Yeah, rolling window, sliding window, whatever you want to call it, definitely something that I recommend for interviews. It comes up all the time because it is kind of easy to understand conceptually, if not, or is in finding the solution. And for competitive programming, it comes up a lot, so definitely practice it. It was a fun problem. Got it on the first try. I don't know whether any hints. No? Okay. In terms of readability, I think this is roughly okay. I think in terms of pure readability, I think adding the delta thing probably made it more confusing than it needs to be honest. But that's okay. At least for this video, it's okay. But you should definitely try to do a little bit better on that. But otherwise, everything else is like 5 lines of code. So I don't really have any way to make it change it a little bit. You could have also used set, which has the same overall complexity, because with a set, you're still only doing the same number of lookups. It just makes this for loop a little bit harder to write, maybe, but not even that much more. But it's still O of alpha because, again, the most number of different things that you could put on the set is only 26, which is the size of the alpha bit, right? So, okay. So yeah, that's all I have for this problem. Thanks for watching. Hit the like button, hit the subscribe button, and I will see y'all tomorrow. Bye-bye.